What's going on, everyone? My name is Johnny Bandon, and I'll be your CCNA instructor for this CCNA video series. In this video, we're going to go over our first Etherchannel lab, which is just going to cover layer 2 Ether channels and then the protocols that the CCNA exam wants us to learn about when configuring an Ether channel. And mainly, this is going to be for the Catalyst Cisco switches, and of course, like our Nexus switches and other versions of switches can also do these Ether channel modes or negotiation protocols. And we're going over these two in particular because that's what's going to be on your exam, or at least that's what's on the exam objectives. So before we start, I'm going to log into my GitLab here. And for our paid students or our students watching free via a streaming service like YouTube, this GitLab is available for everyone. And if you're watching on YouTube, in the description, you should have this GitLab link, which also has the instructions for this Etherchannel lab. And for our paid course students, you should have a direct link right on that course page. And then as far as this lab environment goes, for our paid course students, this lab is going to be part of that download and install package for EvenG that's available to you on our central repository. For our free viewers, feel free to go watch our EvenG how-to videos to see how to create and install EvenG yourself and recreate this lab. Awesome. So what I'm going to do here is open up my lab instructions. I'm going to bring it off to my second monitor over here that you guys can't see. But as you see here, it has the network diagram and the instructions. Awesome. So step one is going to be turn on all devices. So we're going to come here to more actions and start all nodes. And then once we've started all nodes, step 2 says paste baseline from GitLab. So for our paid users, your switches and your network devices in every lab, except I think the first VLAN lab, you should already have that baseline config, and anything else that needs to be configured that doesn't pertain to the technology, like these VLANs here, should already be configured as well. But for our free viewers, please feel free to go to GitLab to the root of our repository and grab a Cisco switch baseline. Okay, now let's move on. Step 3. From switch 1 to switch 2, create a layer 2 Ether channel using an open standard Ether channel negotiation protocol. So let's go ahead and do that. So from switch 1 to switch 2. So we're going to console into our network devices here. And I'm using Secure CRT as my native console application. And then under step 3, we also have a couple of sub steps, I guess, or instructions that says switch 1's interfaces should be actively sending negotiations, and switch 2's interfaces should only be receiving/accepting negotiation messages. So what does that mean? So what we're trying to say here is that switch 1, we're going to be performing LACP negotiation on this Ether channel, and we want its mode to be active. Because if you remember from our lecture, LACP has two modes, one being active, the other being passive. And when you configure your member interfaces in a channel group using active mode, they're going to be sending those Ether channel negotiation messages. And then passive, when you configure your member interfaces in a channel group using mode passive, they're just going to be waiting for that negotiation from the other side to form that Ether channel using LACP. So with that being said, let's go ahead and get started. So first thing I'm going to do is kind of just expand this Secure CRT session so we can get a nice clear view. Okay, and I'm going to start over here on switch 1. Cisco is the username and password. Let me make sure I don't fat finger it. Awesome. On switch 1, we're going to create our Ether channel. So what we're going to do here, guys, is we're going to try to assume that we're taking a real-world approach to this. So what does that mean, real-world approach? Well, we know that in our lab environment here, we have access to these switches no matter what. Meaning whether or not we turn these links off, whether or not this switch has an IP address, we always have console access to them. Well, how many network admins and engineers out there always have direct access to the equipment they're managing? Hardly ever, right? Except maybe your office where you work out of. And nowadays, a lot of people are remote. So if you're tasked to configure an Ether channel, and let's say this switch is connected off to the internet here or an ISP, and you're sitting over here on a beach in Hawaii because you made it big, right? You're the network engineer, senior principal, and you're making good money and you're in your beach house. And let's say this environment we're talking about here is in Arizona. If we go to configure switch 1 first, and let's just pretend that there is no redundant links over here, right? If we go to configure switch 1 first, what's going to happen? Well, once we place these interfaces into an Ether channel, they're going to come down. Okay? So then we don't have access to switch 2. So then we got to put them back to their original configuration and then start all over again. So what we want to do in actuality, right, in reality, is we would want to go to switch 2, and we'd want to configure the Ether channel on switch 2. And we'd also want to probably submit what we call an ASI, an active service interruption, to whoever is in charge, right? Either it's this company letting them know, hey, you're going to come down for maybe 2 hours, give yourself ample time. And maybe we do this at midnight, right? When there's no customer traffic and no profit or productivity being done. And we're going to start on switch 2, and we're going to configure this Ether channel. And before I configure the Ether channel, what I'm going to do is a reload in command. And what that does is say, hey, reload this switch in 10 minutes, no matter what. So reboot the switch. Now, why do we do this? Now, this is just one of the tricks that I've learned, right, over the years, and someone maybe watching this in the comments has a better way of doing this. But essentially, if I create my port channel here, we're going to come down, right? And then I'm going to be kicked back off over to switch 1, depending how I'm remoted in. And then I am going to configure the port channel here and hope that we come back up and I can go back into switch 2. Now, what happens if you make that change and then you mess up configuration and you can't remember what you did and these don't come back up? Well, now you just lost connectivity to this switch, and your 2-hour ASI may have turned into a bigger deal because now you got to call someone in the local area and say, hey, go reboot that switch or go reconfigure it. So what this reload in command does it says, hey, reload in 10 minutes. And by doing that, we put that switch back to its original configuration where we can then start all over again and try to configure the channel the correct way. So that's how I'm going to do this first Ether channel, just to show you some real world stuff. And then we can configure the rest just quickly, like we are in a lab environment, right? Where we can make mistakes. All right, so let's go ahead and do it. So we're going to start on switch 2 because we're pretending we're remoted in from our Hawaii beach house. Awesome. And what we're going to do here is that reload command I was talking about, do reload in. And I'm going to just do 30 minutes. And we want to hit no here, right? Or actually, excuse me. We want to hit yes here. Yes, we want to save the current configuration we have because we know we're up right now, right? So we have a reload requested in 30 minutes. And now let's get into the actual configuration. So first thing we're going to do here is see if there's any current configuration on our member interfaces. And if there was, then what we had to do in an active network is something like this, right? We'd have to go one at a time. So we'd have to go make a script, is what I like to call interface ETH1, channel group 5, mode active. And we do this one interface at a time. So what we would do here is just go ahead and put this in, copy, and then paste. And then in a real world environment, we may get kicked out or we may not, just depending, because we have those dual links, right? So we may have some downtime and then STP, spanning tree reconvergence, and then we'd be back online. And then I would paste in for 0, 0. And then, actually, this script, I'd have it like that so it automatically does it for me. Hit enter, and then we'd be kicked out of this switch. And then what we would do is we would come to switch 1. We type in interface Ethernet 0, 0, range ETH 0, 0 through 1. We type in channel group 5, mode passive. And then we'd hope this Etherchannel would come up and we'd get access again. And then we'd go into our configuration of the actual port channel. So what we would do here is type in do show Ethernet channel summary. And we can see that we did come back up. So our Etherchannel is bundled, it's layer 2, and it's in use. So we had no issues here. Now you may be wondering, well, hey, isn't there a way that we could leave one trunk on and do this one step at a time? And you're right, there is a way, but even if we did it one interface at a time, so let me break this down. So if we decided to come here, put ETH 0/1 into channel group 5, leave 0, 0 the same, come back to switch 1, put ETH 0/1 back into port channel 5. These could be doing a port channel, and then go back to switch 2, change ETH 0, 0 into the port channel. Would we still have access? Well, potentially we would, because 0, 1 and 0, 1 would still have good connectivity, and then we just put 0, 0 into the bundle. That is one way we could go about doing this. And then we'd have to go into our actual port channel now and do our trunking commands if we wanted to make a trunk out of this. So right now we would probably just be doing communication over VLAN 1 or whatever the native VLAN is. So when we're remoting in, we want to make sure that the VLAN 1 has a IP address assigned to it. And I'm going to show you guys that when we go over switch virtual interfaces. Okay, so now let's get back to our configuration. And now we're going to go into our port channel that was created. So if we type in do show IP interface brief, then pipe include capital P. So using this pipe command, we can just see our port channel configuration or our interface created. Now let's go in and make a trunk on this port channel. Port channel 5. And we're going to type in switch port trunk encapsulation.1q, switch port mode trunk, then switch port no negotiate. And we're going to do the same thing on switch 2. Our port channel is going to come down, because another important thing about Etherchannel, guys, is that both sides have to be configured the exact same way or Etherchannel won't come up. So even if all 4 ports are configured as trunks, but Ethernet 0, 0 doesn't have that switch port no negotiate command, that port will never become part of that Etherchannel bundle. Every single member interface and the port channel interface configuration has to be the exact same. So we're going to do that. Switch port trunk encapsulation.1q, switch port mode trunk, then switch port no negotiate. As you can see here, our port channel did come down, and then we suspended our member interfaces because we configured port channels here on switch 1, and switch 2 did not have that same configuration at the time. So now let's type in show Etherchannel summary and see if we're back in business. It looks like we're not. So now let's do some troubleshooting, right? And this is what I mean by how finicky these Etherchannels are. And when you're doing it in a real world environment, you definitely want to make scripts for it, maybe in Notepad or something like VS Code. And make sure you run this in a lab at least 1 or 2 times, right? Especially if you're not on location to actually console into these devices like physically. So what I'm going to do here is just compare our member interfaces with this command, do show run interface ETH00, do show run interface ETH01. I'm going to do the same thing on this switch 1 here. So do show run interface ETH00 and 01. What I'm going to do here is drag this off to the side. And now we can do some comparisons. So what do we already notice, guys? Is that on switch 1, we have the switch remote trunk command actually configured on the member interfaces, but not on switch 2. Now, why is that? So by default, in Cisco best practice, they say when you create an Ether channel, that the first step is to create the Ether channel. Create the Ether channel, meaning go to the member interfaces and put them in a port channel, right? Channel group 5 mode active. And then step 2, they say to now configure the port channel with all the configuration. So with your trunking configuration. And they say that when you configure from the port channel, it's supposed to push that entire configuration down to the member interfaces. Well, we can see that's not true in this case. What we see here actually is that on switch 2, even though we did the switch port mode trunk command on the port channel, it didn't push it down to the member interfaces. Let's go ahead and fix that. And what we're going to do here is try Cisco best practice one more time by typing in the switch port mode trunk command on the actual port channel. And then we're going to check our interfaces again. And still, no luck. So now before we actually configure the member interfaces themselves, go in there and just configure them like we normally would, let's just take a look at our port channels and make sure they're the same. They are. And now let's go in and actually configure our physical member interfaces to have that switch port mode trunk command. Okay, and see we have another error here. So what we see here is that an interface whose trunk encapsulation is auto cannot be configured to trunk mode. Another issue. So what could be the problem here? Well, it says that our encapsulation is .1Q, but this error is saying, no. We don't know the encapsulation yet. It's set to auto, so you can't put us in a trunk mode. The typical command error you'd see if you try to do this with just a singular trunk port, right? So what show commands do we have to actually check to see if these physical interfaces are actually not set? And you can see here that the trunk or the encapsulation is on auto negotiate. So even though, so let's just take a step back here and go over what I'm saying. So when we try to apply this switch port mode trunk command, it says, you can't, brother, because your encapsulation is set to auto. But we see right here that that's not true. It literally says switch port trunk encapsulation .1Q right here. But we're still getting this error. So we run this command, do show interface ETH00 switch port. And this is actually going to show us what's actually happening on the hardware level. And yeah, it's saying that the encapsulation is set to negotiate. So my best guess is none of the port channel commands actually got pushed down to those interfaces, despite what the running configuration is telling us. And again, Etherchannel is a little finicky. So let's just go ahead and go against Cisco best practice and configure these directly, these member interfaces. Let's shut them or flap the links and then no shut and see if our Etherchannel comes back up and see if we become bundled and passing traffic. So we see our physical interfaces coming up and then it says LACP currently not enabled on remote port. So we're back to suspended. So let's just give it a few minutes here, see if that fixes itself. Because sometimes Etherchannel, especially in this even G environment does just sometimes mess up. So let's go ahead and look at our port channel again. And if this doesn't fix itself, we're going to flap the port channel. We're just going to go ahead and default out the member interfaces and then start all over. But let's see if we flap this port channel, see if that fixes it. And still no luck. So what we're going to do here, guys, is just go ahead and default out the member interfaces, get rid of our port channel, and start all over again. And now you're kind of seeing why it's very important that we test out our Etherchannel configuration, right? Really, I knew this was going to be an issue because I've done this lecture so many times in person. For some reason, in EVNG and some real-world switches, the Cisco best practice doesn't always work. So again, it's best to kind of test this out before you actually apply it to a real-world network. So what I'm doing here with this command is bringing these interfaces back to their default. I'm going to go back into them. I'm going to shut them down. And then I'm going to type in channel group 5 mode active. I'm going to do the actual trunking commands to match the other side on switch 1. And then I am going to no shut and see if we come back up and that fixes our issue. Again, we're just going to give a few minutes here. And really the whole point of this lecture, and again, I knew this was going to happen. It kind of just even G with port channels sometimes just very finicky, right? So it doesn't mean you're configuring anything wrong. It just means that, hey, sometimes this port channel just doesn't want to work in even G. And this does happen real world in some scenarios. So let's go ahead and look at our port channel one more time. So you see that the port channel, we're missing our trunk command. So let's go in there. Type in switchport trunk encapsulation.1q, switchport mode trunk, switchport no negotiate. Actually, let's go ahead and flap that port channel. Okay. And then we're going to just flap it, right? Shut, no shut. And we're going to see if our port channel finally becomes bundled and passes traffic and is active to the other side. Still nothing. Okay. So this is kind of good, right? I kind of like doing this live troubleshooting. So everything we know about port channel is that as long as the modes match and everything's the same on both sides, they should become bundled and active. So if we look at that, on both sides, we're the exact same according to the running configuration, but we still are not coming bundled and nothing's happening. So what we're going to do on switch 1 now is do the same thing. Just go ahead and flap this ether channel, see if that makes it come up. And if it doesn't, we're going to do the exact same thing, okay? We're just going to default switch 1 out and start all over again and see if this comes back up and if we can go back to our bundle. So now you see this one's down. So let's go ahead and do that, guys. So first thing first, let's just make sure our interfaces are still in an up state. Okay. So on switch 1, we're going to type in no interface PO5. And then we're going to default out our member interfaces. And then we're going to go back into our member interfaces. We're going to shut them. We're going to do our configuration, channel group 5 mode active, switch port trunk encapsulation.1q, switch port mode trunk, switch port no negotiate. We're going to go into port channel 5, do our trunking commands as well, switch port trunk encapsulation.1q, switch port mode trunk, switch port no negotiate. And then I'm going to go back into my member interfaces and we're going to turn them on. And let's see if we finally come up in our Etherchannel bundle. And if we don't, we're just going to move on in this video and leave it up to, this is just EVNG kind of messing with us, right? Because we're doing everything correctly. We tried Cisco best practice way and we tried not Cisco best practice way. And look, now we finally are up. After all the pain, sweat, and tears, we're finally bundled. And as you can see here, again, Etherchannel is not something you don't want to plan for, right? Again, I knew an evangelical was going to be an issue, but every class, I like to just show you like, hey, this is the exam, but real world, you don't want to be in a situation where now your switch is not reachable because of the mistakes you made and you didn't properly plan, right? So in switch 2, we're going to get rid of that reload in command to make sure that we don't reload. No. Reload cancel. All right. So now we canceled that reload and we're bundled now. So that was step 3. Now let's move on to step 4. And we're just going to create an ether channel using PAgP. So that's going to be from switch 1 to switch 3. So I'm going to go ahead and console into switch 3 as well. And we're going to do this step by step, okay? So from switch 1 to switch 3, we have interfaces 0, 2, and 0, 3. So what we're going to do here is type in interface range, ETH 0, 2 through 3. We're going to shut them down, create our channel group. And then one side's going to be actively negotiating and one side isn't. We're going to type in our trunk commands here. We're going to go into that port channel, do the exact same thing, put in our trunking commands. And then I'm going to leave those interfaces shut. We're going to have them both come up at the same time on both sides. Switch 3, interface range ETH 0, 2 through 3. Channel group, again, this number has to match. We're going to put it in auto. And this is just going to be receiving, not actively negotiating for PAgP. And then we're going to do our trunking commands. Actually going to shut these interfaces down as well. Switch port trunk encapsulation.1q. Switch port mode trunk, switch port no negotiate. And then we're going to go in to the port channel, do the exact same thing. Switch port trunk encapsulation, switch port mode trunk, and switch port no negotiate. Then we're going to go back into our member interfaces. And we're going to no shut. We're going to try to do this at the same time. 0, 2 through 3. No shut, enter, enter. All right. So now let's see if our PAgP connection comes up. And we should have no issues here. It should just come right into a bundled state. So you can kind of see here when we properly plan our ether channels that it really is no issue. And we can see that we're bundled, we're layer 2, and we're in use. So step 5 says verify the ether channels have been created. And then let's perform a Wireshark capture on both ether channels and notice the difference negotiation protocols. So what we're going to do here is just go ahead and go into port channel 5. And let's shut it. See if that ether channel comes down. Yep. And then let's do a Wireshark capture on ETH 00. And then we're going to no shut, and we're going to see the LACP negotiation messages hopefully come across. Okay, come back. Let's no shut that port channel. All right, and then I'm going to bring my Wireshark capture into view here. We're going to pause it. Come back up. And here we see the LACP protocol here. So we see the active negotiations being sent. And look, we can kind of break down this LACP here. So a lot going on, but this is what the negotiation message looks like. On the other side, the PAgP is actually going to be part of the CDP discovery protocol. So let's go ahead and take a look at that. So we're going to get out of here. We're going to go over to switch 3. We're going to go into port channel 10. We're going to shut it down. And then let's go ahead and capture 02. Because I believe switch 1 is doing the active negotiations. We should still see them on either side. All right, and now let's no shut. Okay, I'm letting the Wireshark capture run, waiting for the port channel to come up. Okay, awesome. Now let's take a look at this Wireshark capture. So we can come in here. This is about when it came up. And in that Cisco Discovery Protocol, where is it here? We should be able to see a PAgP message coming across. I don't see it here. Oh, here we go. It's going to be actually right here. You see the protocol PAgP. And we see that port aggregation protocol being sent. All right. So those are the kind of the differences between the two. Now for our last step, it just says configure the bottom two switches in any protocol of your choice. So I'm going to let you guys do that in your own lab because I don't want this video going too long. And I want to thank everyone for viewing and stay tuned for our next Etherchannel lab. We're